All right, so when we use equations to model real-world problems, we often look to linear models first because they are the easiest to use and understand. So all linear models are in the form of y equals mx plus b. They have two parameters, the slope m and the y-intercept b. The slope always tells us how fast the output is changing relative to the input, and the y-intercept b always tells us how much we start with. So let's say that Janine has $450 in her savings account at the beginning of the year. She places money in the account at the rate of $5 per week. We want to model the amount of money she has in savings, S, as a function of the number of weeks she's been saving, W. So at 0 weeks, we know that she has $450. We're not going to add anything because there's 0 weeks. It's what she's starting with. So now we do 450 plus 1 times 5. Well, 1 times 5 is 5. 450 plus 5 is 455. Then we do 450 plus 5 times 5 because it's telling us that we have 5 weeks here. Well, 5 times 5 is 25. 25 plus 450 is 475. And then 450 plus 10 times 5. 10 times 5 is 50. 450 plus 50 is $500. So use information in the givens or in the table to write an equation for the savings S as a linear function of the week she's been saving W. So her savings is always something times W plus something. Well, we know that she's getting $5 per week, and she started with $450. So if Janine saves for exactly 1 year, what is the range in her savings over the year? So 1 year is 52 weeks. So we're going to we want to know what is her savings at 52 weeks. Well, 52 times 5 is 260 plus 450. So her savings after a full year is $710. So she starts at 0 and goes to $710. So to show her range starts at 0 and ends at $710. Why would it not make sense to evaluate 6.5? Well, let's talk about what kind of numbers belong in this. Do you really go 6.5 weeks is when you put money in, or 6.2 weeks, or 5.2? No, you do at the beginning of the week. So you can't necessarily have 6.5 weeks. Doesn't work. So it has to be whole numbers. So use 2 points from the table to verify that the rate of change is 5. So let's use the point 0, 450 and the point 5, 475. So change in y from 450 to 475 is plus 25. Then from 0 to 5 is 5. So our rate of change is 5. All right, let's say that Kirk is driving along a long road at a constant speed. He's driving directly towards Denver. He knows that after 2 hours of driving, he is 272 miles from Denver. After 3.5 hours, he is 176 miles from Denver. So we have information for 2 ordered pairs. Here's our first ordered pair. Here's our second ordered pair. So our first ordered pair is, remember, time is always the x, so 2 and 272. And our second one is 3.5 and 176. Now we're going to calculate the information and include the proper units in our answer. So this is saying the distance of 3.5 minus the distance of 2. Well, it's really just saying our change in y. So from 272 to 176. So 272 to 176 is negative 96. Then from 2 to 3.5 is positive 1.5. So 96 divided by 1.5 is negative 64. So it's going 64 miles per hour. You should have found that the rate of change was negative, right? Because you go from farther away from Denver to closer to Denver. So you're going from, it's talking about how close you are to Denver. Assuming the relationship is linear, which it would be at a constant speed, write an equation for the distance d as a linear function for the number of hours h. So we know, so d equals mh plus b, that our slope, our rate of change, is negative 64. We still don't know b, but we can use one of our coordinate points. I'm going to use the coordinate point of 272. So negative 64 times 2 is negative 128. So 272 equals negative 128 plus b. So we're adding 128 to both sides. So 400 is b. This means that they started 400 miles away from Denver. So our equation is d equals negative 64h plus 400. What this means is that he started 400 miles away, and every hour he is getting 64 miles closer. So after how many hours will Kirk arrive in Denver? So we want to know how long will it take for him to be 0 miles away. So subtract 400 from both sides. And now I have negative 400 equals negative 64h. Divide everything by negative 64, and 400 divided by 64 says that it will take 6.25 hours to finally get to Denver. And finally, Amanda is walking away from a light pole at a rate of 4 feet per second. If she starts at a distance of 6 feet from the light pole, which of the following gives her the distance, d, from the light pole after walking for t seconds? So, she starts 6 feet away, and she's walking away from it. She's not walking towards it. So they're both going to be positive. So if she starts 6 feet away and she goes 4 feet per second, then this is your equation.